Hello, good morning, everyone, and welcome to today's SIICaP webinar. My name is Jo Briones of the Public Relations and Information Division, and I will be your host for today's session. So our session today is the third and last part of the Space Data Mobilization series, and we will be exploring the applications of Earth observation in agriculture. Today, we will be hearing some of the experts in the field who will share their insights, experiences and case studies on the impact of Earth observation data on agriculture. We would like to acknowledge our participants from the various local government units, national government agencies, colleges, and universities who are here with us today. Thank you for joining us. I'd like to know if I'm audible right now. Can I get feedback from our audience kung okay lang po yung audio natin today? Right? Parang may mga nagcha-chat yata. Okay. All right. Thank you so much sa mga nag-respond. We'd like to also tell you that we are also live on our YouTube channel at PhilSpace Agency, and the live stream link is also on our Facebook page, facebook.com/PhilSpace Agency. So let's have a shout out sa chat po natin. Where are you guys from? What agencies or schools or are you representing? Meron po tayong okay. Meron tayong from LGU sa La Libertad. Saan po galing yung iba nating at iba nating guests? Oh, we have representatives from UPLB and UPOU and La Libertad Negros Oriental. Thank you very much. Thank you very much for joining us today. We also have representatives from Negros Occidental, Quezon City, ayan, QC CCESD, yung mga taga-PhilSA dyan, Philippine Space Agency. Sound off din kayo sa comment section natin. Thank you very much. So yeah, I guess, thank you very much. So I guess you guys are alive, alert, awake, and enthusiastic. But before we start, just a few reminders for our audience. So if you have any questions for our speakers, please don't hesitate to type your questions in the Teams chat. Pwede din po kayo mag-raise ng hand mamaya during the Q&A portion. But you can drop your questions anytime po dito sa Teams chat po natin. And for our audience din sa YouTube, please just post your comments dyan sa live chat po natin and we will answer them during the Q&A session. If you have further questions after the event, please feel free to send them to SIICaP@philsa.gov.ph. That's SIICAP@philsa.gov.ph. Somebody will be putting that email address in our chat box for everybody's reference. Ayan. So to officially start the program, we would like to call Engineer Nico Pante, the project leader of SIICaP, to give his opening remarks. Nico, take it away.
Hello everyone. Happy TGIF. So welcome sa ating final installment ng Space Data Mobilization. Dito sa final iteration natin, we will focus sa agricultural application ng satellite data. Trivial naman sa atin na ang bansa ay may malaking sektor sa agrikultura. So base nga sa literature, 1/4 ng employed Filipinos ay nagtatrabaho sa sektor na ito. At noong 2021 may 9.6 share ito sa GDP ng bansa. Lalong nagiging critical ang agrikultura dahil sa pagtaas ng demand sa pagkain. Kailangan natin itaas ang production habang binabawasan ng environmental impacts. Ito ay malaking challenge. So gamit ang satellite technology, napakita na natin sa mga naunang webinars kung paano ito gamitin upang makapag-monitor at mag-analyze ng changes over time. Sa webinar na ito, may matututunan tayo ng iba't ibang gamit ng satellite data tulad ng pagtukoy ng dry area, soil moisture, pagmapa ng crop, at iba pang uri ng gamit nito sa bansa. Makikilala din natin ng ilan sa mga experts na magbabahagi ng kanilang kaalaman, experience at insight sa paggamit ng satellite data. So kung kayo ay agriculture specialist, farmer, researcher or interested lang sa topic, we hope that you will find this webinar informative. And lastly, please don't hesitate to ask questions. Ayun lang po. Thank you.
And thank you very much, Nico, for your welcoming remarks and for telling us what's the importance of holding this specific iteration of our SIICaP webinar. Yan. So, handa na ba tayong lahat? Okay. Yes, very active po yung mga participants po natin sa ating teams. Marami po silang comments. And I think they will have more comments later during the presentations of our esteemed speakers. So let's move on to the next part of the program, which is our first presentation today, titled Agricultural Drought Monitoring from Space. To present this is Miss Dana An. She is a science research specialist in the Earth Sciences Space Mission Studies Division. Just a brief background on Dana. She finished her Bachelor of Science in Applied Physics and Master of Science in Meteorology degrees, both from the University of the Philippines, Diliman. As part of the second phase of the Drought and Crop Assessment and Forecasting Project funded by DOST Picard, she was in charge of continuing the drought forecasts and automating the early warning system. While she works as a computer programmer and researcher, she also enjoys designing her own origami from time to time. Let us all welcome Ms. Dana Ang.
Hi, hello. Morning. Kita po ba yung
Morning.
kita po ba?
Yes po, you're visible and you're audible.
All right, I shall share my screen. All right, can you see my slides?
Yes po, visible po yung slides nila.
All right. Magandang umaga mga kapwang sumisikap. Good morning, fellow SIICaP enjoyers. I am Dana Ang, and I'll be talking about the highlights of the research I've been involved with for the last few years. Essentially, we'll tackle this by dividing the titles into 4 parts. First, we'll talk about drought and then go specifically to things to look out for in agricultural monitoring, and then discuss how satellites in space can help us, and then finally tie everything up with agricultural drought monitoring and assessment. But first, let's talk about drought. We know that agriculture is an integral industry for the Philippines, but to drive home the point, did you know that as of 2019, 22% of the Filipinos are in the agricultural sector? That's 1 in 5 Filipinos, and that around 40% of the entire country is classified as agricultural lands. The annual national level rice production has been steadily increasing since 1987, but there are dips in this annual trend. Can anyone type in the chat, what are these pink lines representing? There are certain years that happen, that there's something happening. Can anyone type it in the chat? It's not, well, it's not exactly drought, but yes, it's a related concept. Oh, there, I see answers. El Nino, yes, that is correct. So the El Nino phenomenon is closely tied to drought in the country. And to give you an example, for the recent 2018 to 2019 El Nino, it brought about almost 8 billion pesos in damages in the agricultural sector. Angat Dam reached critical levels, and the heat index, or the temperature that we feel, reached as much as 40 degrees Celsius, but this actually was even higher for other provinces. But of course, what is El Nino in the first place, as not everyone may be familiar with this concept? El Nino is a recurring part of the global climate system. During neutral years or normal years, the sea surface temperature around the Western Pacific Ocean and Southeast Asia is warm, there is evaporation, convection, rain, rain, and more rain. So you'd think, why would a country such as ours ever experience drought with all this rain and typhoons passing through every year? Well, every 4 to 7 years, the eastern Pacific seas become warmer, taking away the center of convective activity and all that rain, leaving us with drier conditions, favorable for drought. But let me make this clear, drought in the Philippines is not always caused by El Nino. There can be neutral years that do have drought, but when there is an El Nino, there is a good chance that at least one province in the country will experience drought, sadly. But I've been rambling about drought all this time, but I haven't even defined it yet. But maybe some of you already have some ideas. Let me know in the chat, how do you think we know that drought is happening? Do you see it outside happening? What are the indicators of drought that you know of? Do you see it happening outside in the fields? Is there a cloud passing through, burning every crop and plant out there? So we have here some answers. Depends on temperature, stream flow, ground and water reservoir. Thank you, John Rosales. Yes, those are good answers. Visible wilting of plants, very low average rainfall, 3 months consistent below average rainfall. Yes, those are a more technical definition. Thank you. So those are all different manifestations of drought that I will be talking about more in the next slide. But in essence, researchers and policymakers have debated on the exact definition of drought. And as you have suggested, drought is defined in terms of the specific context or application. So there is no one definition that fits all. But to give you an idea, the World Meteorological Organization defined drought in 2006 as follows. Drought is an insidious natural hazard characterized by lower than expected or lower than normal precipitation that, when extended over a season or a longer period of time, is insufficient to meet the demands of human activities and the environment. So some things to take note of: lack of rainfall is the root cause, and we are not talking about the weather anymore since we are looking at extended periods of time. This is in the domain of climate. And all this will lead to a negative impact on the environment and society. So we look at the four main types of drought. First is the meteorological drought, which is tied to precipitation deficit, lack of rainfall. And this is the primary type of drought monitored by our local weather bureau, Pag-asa. But they also deal with the next two types, which the next one is, of course, agricultural drought. When lack of rainfall leads to lower soil moisture available for crops and crops die, that's agricultural drought. Then we have hydrological drought, which is now more related to stream flow, and it deals with water storage found in rivers, dams, and lakes. While for socio-economic drought, it occurs once we look at the perspective of the market to see if there is a shortage of goods due to drought. For today's SIICaP webinar, we're focusing on agriculture. So I'll briefly talk about the things to look out for in agricultural monitoring, especially for field validation. First, for the vegetative conditions, you have to know your crop type and their water requirement. Because, for example, corn is more drought resilient than rice, but since we all love rice, we'll continue to plant and eat rice. Next is the cropping cycle or the crop stage. And typically, drought impacts would be worse during the growing season compared to when drought happens later during the harvest. And next, we don't want to know the overall health of our plants. But since there is no floating HP bar in real life, we resort to indirect methods to quantify the health. The examples include plant height and chlorophyll content to check if the plants are growing as they should be. And in addition, beyond just analyzing the plant health itself, we look and analyze the surrounding environment. For example, we look at the time of day. Chlorophyll measurements are only valid during the day, and some instruments may not work if there is rain. So we try to organize field work outside of the typical rainy season. And in addition, we can also check the air temperature, the humidity, soil moisture, and soil chemistry to see how suitable are the environmental conditions for growing. So that was a pretty short section, but since I'll also integrate the topic of agriculture to the next part, I will now proceed with the third one. The question that some of you may be wondering, or some of you already know the answer is, which of these parameters can we see from space, which is hundreds to thousands of kilometers from the ground? I'll first talk about the technology for Earth observation that some of you may all be familiar with. Satellites use remote sensing technology to take images of the same area at different times, and this is useful for climate monitoring. The Global Climate Observing System has identified 54 essential climate variables, the minimum number of parameters needed to describe the global climate system, and more than 2/3 of those are monitored from space. Satellite remote sensing is possible by sending and receiving electromagnetic radiation emitted by various components of the Earth. And by looking at specific wavelengths, we can infer the conditions at the surface. For example, true color images that we see from Google Earth rely on wavelengths 10 to the -7. And also look at surface temperature at the micrometer scale. And then at the millimeter to centimeter, we can infer rainfall and soil moisture. And from the centimeter to decimeter scale, we can actually generate rice maps. At this point, I'd like to rebrand some of the concepts I talked about into a drought-centered definition. The environmental parameters I will call as drought indicators since we monitor their behavior through time. And these are derived from the raw images or satellite radiances that the sensors collect. And two of the drought indicators that we will look at are rainfall, which we take from two satellite sensors at 10 to 25 kilometers resolution. And we'll also look at land surface temperature or LST, which is at 5 kilometers resolution. Next, we'll look at drought indices, which are essentially numbers derived from drought indicators or even other drought indices to quantify the severity of drought. This has the same idea as asking you how good your breakfast was from a scale of 1 to 10, with 10 being the highest, where we arbitrarily assign numbers with an equivalent rating. So in our case, it would be we could assign a certain number, such as 0 for no drought, and then 1 with having drought, and maybe a number 2 for signifying severe drought. Here are some of the drought indices that we will tackle today, but I don't mean to intimidate you with all the long names and the equations, but for those of you that can appreciate equations, maybe you see here how similar these indices are to one another or how different they are. The Normalized Difference Vegetation Index, or NDVI, deals with the quote-unquote greenness of plants. It is a measure of how green the area is. And it is also sometimes used as a drought indicator because it is used as an input to other drought indices. We have next the Standardized Precipitation Index, or SPI, which is an interesting index because it only uses rainfall and it accumulates rainfall for certain months, and it can actually be used to monitor different types of drought, whether be it meteorological, agricultural, or even hydrological drought. We then have the last two, the Vegetation Health Index, or VHI, and the Standardized Vegetation Temperature Ratio, SVTR, which are both based from LSD, our temperature, and NDVI, our vegetation health, but they have a different formulation and we might see different things. So now I'll tie all this together with agricultural drought monitoring from space. Some highlight in the course of the satellite-based agricultural drought research that I've been involved with is through Project DECAF, or the Drought and Crop Assessment and Forecasting Project, funded by DSTP CARD, and this was implemented by University of the Philippines, Diliman Institute of Environmental Science and Meteorology, alongside DOST Pag-asa and the Department of Agriculture, Bureau of Soils and Water Management. The project started in 2013, but I only came 2018, and the project ended last 2021. And afterwards, there's a brief consultancy with Red Cross. And now, with the establishment of the Philippines Space Agency, we now have a project that continues the satellite-based agricultural drought research. So from here on, I will be focusing on the results of our research for analyzing the 2018 to 2019 El Nino-driven drought. First, looking at the drought development at the country scale, and then going to the local scale, especially in Occidental Mindoro. And lastly, I'll show the potential of the Combined Drought Index, or CDI. The strength and duration of the El Nino phenomenon is described by the Oceanic Nino Index, or ONI. And here we have the El Nino threshold at 0.5. And the 2018 to 2019 El Nino is considered a weak El Nino, but it spanned for 10 months. So this long period of rainfall deficit truly affected the country. Looking at the country scale development, we have here the monthly maps of rainfall at the top for January to April, and we have LST, or the temperature, for January to April as well. And we see that the rainfall deficit started from the western regions in Bicol and western Visayas, and then it started to spread in February and then March, and then sort of died down in April. And while for LST, the elevated temperatures heightened the effect of the dry season, which is typically in March to May for the western side of the country. Sorry, eastern regions rather, for the rainfall deficit. And now moving on to SPI, the Standardized Precipitation Index, which is the index that is only based on rainfall with only 1 month reference for accumulation. It identified meteorological drought starting in February and then moving on to March. But looking at SPI3, which takes into consideration 3 months worth of rainfall data, the water storage deficit already had some signals in January, although it died down in February but recurred again March and April. Looking at the vegetation response from the NDVI, we notice that there are only drought signals or the areas in red starting from March. So there is sort of a lag effect that occurred. First, there are signals in rainfall and then the vegetation followed after. Looking at our vegetation temperature-based drought indices, SPTR and VHI, they actually had a similar maps, not exactly the same, but similar concentrations to where there were severe drought that happened. In March, it started in North Luzon around the Cordilleras and Cagayan Valley. And then in April, it spread through the Bicol region and Visayas in April. Now taking a closer look at Occidental Mindoro, we have here the total damaged hectares per municipality. Because at the end of the day, we want to resolve what we see from the satellite with what actually happened on the ground. And we see that there are more damages towards the south part of Occidental Mindoro. And looking at the satellite-based indicators, the NDVI and our drought indices showed concentrations of drought intensity towards the center of the province of going towards the south for both drought intensity and drought density. Now we look at the potential of the combined drought index for monitoring drought, because so far we've only dealt with indices that combined one or two variables. Now we try to integrate these three: rainfall, temperature, and vegetation health. If you look at the literature, there are different formulations for the combined drought index, but in our case, these are the three parameters. When there is a rainfall deficit, CDI notes it as a watch condition, and then when there is both a rainfall deficit and increased temperature, then we go to the warning stage. And alert 1 occurs when there is vegetation stress paired with either rainfall or temperature, and we have alert 2 stage when all of them are telling that there is drought. Looking at the month-to-month map for still the 2018 to 2019 El Nino, we have here the CDI maps, and the Philippines started out as green with normal conditions, and you see provinces with yellow colors denoting the watch condition going on from October, and then there are actually some areas with alert 2 in even before 2019. But we go look here at March, and then we have alert 2 in the Cordilleran region, and then April 19, the alert 2 spreads downwards, spreads south. Looking at the percentages of the CDI, we see here that the watch signals reach around 60% in March, and around 10% are in alert 2, and this doubles to 20% in April. And And lastly, we check the performance of CDI in the middle here and tells us the number of drought events that occurred in the period with the actual rice and corn damage due to the El Nino here at the left part. And to the right, we have the accuracy assessment for CDI. And to see whether or not CDI actually tagged a province drought correctly, which is in the dark blue, or if it didn't, in the other colors. And compared to the performance of the other indices, SPI3 and VHI, CDI actually had a higher hit rate compared to VHI, having 85%, and it had a lower false alarm rate compared to SPI3, 59%. Although there's still much to be decided, as we'd like our false alarm rate to be 40% or even lower. But essentially, this is all still research in progress. So essentially, what's next? As of now, we are currently in La Nina phase, or the current La Nina is ending, and by the end of the year, we are seeing a more than a 60% chance of El Nino occurring by the end of 2023 and continuing on at the start of 2024. And hence, agricultural drought may occur by next year. And so you'll have to take into account the different preparations for the succeeding cropping seasons in light of what could actually happen next year. So, in conclusion, drought indices captured the drought development associated with the 2018 to 2019 El Nino at the country level and for Mindoro. The combined drought index, sorry, it's not complete, is a promising drought index for accurately determining whether drought occurred or not. And continuous monitoring is needed for the expected El Nino later in the year. So that is all from my end. Thank you for listening. And I'd also like to thank the following entities that made this talk possible. Thank you.
Thank you very much, Miss Dana, for that presentation. That was very informative, and I think nakaka-relate yung iba nating mga participants here because we have representatives from DOST, Pag-asa. I think we also have. I think your mic, yes, okay. And I think they might have questions for you as well. Meron na po tayong mga tanong sa ating chat box. So, ma-address po natin ito sa ating Q&A portion after our next speaker. But don't worry, you could still put in your questions and you could still raise them later on. Ayan, maraming salamat po sa mga questions na. We will address them later. We also would like to shout out yung mga viewers natin on our YouTube. We have viewers from Surigao Norte State University main campus. We also have viewers from LGU Iligan City. So we have participants all over the Philippines. And meron na rin tayong mga questions on our YouTube video. So keep them coming. Thank you guys so much. Yan. Abangan po natin yan, yung Q&A natin with Ms. Dana later. But before that, let's move on to the next presentation entitled Sugar Regulatory Administration's Application of Satellite Data. So this was supposed to be presented by engineer Laverne Olalia, but he had to attend to other things. So this will now be presented by Mr. Rolando C. Torres. Sir Torres is a graduate of a Bachelor of Science and Information Technology degree from the STI College in San Fernando. He has been working in SRA, or the Sugar Regulatory Administration, since 2015 and has handled 3 positions since then. Currently, he is a Geographic Information Science Specialist of the department. Let us all welcome Mr. Rolando C. Torres of SRA. Round of applause, please. I believe he has a presentation. hand. So let's start playing that presentation and paki-inform po kami if meron pong audio.
Good morning, everyone. So I will be presenting how these satellite data are being used in agriculture. Basically, I will be sharing with you our project in Sugar Regulatory Administration, which is the yield estimation system for sugarcane, which being handled by the crop estimating headed by Engineer Laverne Olalia. This is launched in order to generate rapid, realistic and science-based estimate on annual cane production. Using the remotely sensed data, field data, and weather data, we are able to generate outputs such as NDVI maps, yield maps, area estimate, and other relevant information, which this data we can provide an estimate that is very relevant to our agency. Ano nga ba ang mga technology na ginagamit namin sa crop estimate system? So una, ang GPS technology. Pangalawa, Geographic Information System. Pangatlo, remote sensing. And the last, the machine learning. So GPS stands for Global Positioning System, which is a satellite-based navigation system that provides location and time information anywhere on near the Earth's surface. It is used network or orbiting satellites to transmit signals to the GPS receivers on the ground, which can be calculate their exact location. Also, GPS is widely used in a variety of applications, including navigation, surveying, mapping, and trucks, among others. So we use Garmin GPS and Osman, an Android application for validation and mapping of sugarcane plots. Basically, the essential inputs of our system is the parcellary mapping of sugarcane. We collect basic information like planter name, variety, furrow distance, and other information that embeds on our GIS data. But the most important information to us is the parcellary mapping that has exact location and exact boundary of sugarcane plots. So when we process the data in remote sensing, we come up an accurate data. We also conduct sampling on the 8 to 12 months old cane. We collect data including number of plots per meter, stalk height, diameter, weight, and other information. This will serve as supporting data on our yield estimation. GIS stands for Geographic Information System, which is a computer-based system that allows for us to collection, storage, analysis, and visualization of geospatial data. GIS combines of hardware, software, data, and people to create maps and other visualization that helps users to understand the patterns and relationship in geographic data. GIS can provide valuable insights and information for decision making in a variety of fields that can help individual and organization for better understanding on a spatial patterns and relationship. So ito po yung mga sample output namin using GIS and RS. So we have soil type mapping. In agriculture planning, it is extremely important to know the different type of soil and crop they can support. This information, if we use effectively, we can greatly improve the agricultural output and its quality. Rivers and water resource mapping. These maps show the geographical location of different rivers and its distributary system around the area. It can be used in locating the nearest source of water and designing a canal system. Elevation maps. This map shows the elevation data of various geographical features on the Earth's surface. So, ito po yung mga output naming maps. Hindi lang po yung elevation, water resources, and soil texture ang ginagawa namin po. We have also elevation, soil erosion, soil texture, and soil fertility map. Those maps plays an important role in planning. Like, for example, we have data on elevation and soil type or texture. We need to consider that those map or data in designing and planning what kind of irrigation system are applicable in a specific area. Also, we have output on fertility maps. These maps serve as a guide on what kind of fertilization or fertilizer is needed on our soil. So third, remote sensing means to the collection of information about the Earth's surface using sensors that are not in direct contact with the object or the area being observed. This typically done using by satellite, aircraft, or drone-based platform that capture images and other data from a distance. Remote sensing data can include a range of information such as visible and infrared lights, radar signals, and other electromagnetic radiation signals. By analyzing this data, remote sensing can provide information about land use, vegetation, water resources, atmospheric condition, and other features on the Earth's surface. So the main advantage of the satellite or the aerial images over our traditional system, or the field-by-field implementation of crop monitoring is monitoring in compared to this system or the satellite imagery. It's provide objective and especially explicit observation of the crop productivity over the large area in a short period of time. Over the 384,000 hectares of sugarcane in the Philippines, this is what we need in rapid assessment of our crop, giving the status of our crop in a near real-time data. So we are also using NDVI, or Normalized Different Vegetation Index. Nag-research po kami dati nung ginagawa pa po yung system, at may existing na study regarding the NDVI ng frequency ng tubo. According to the study of Radman, the NDVI values of sugarcane is between 0.20 to 0.60. At ang lower upper limit ng good condition ng sugarcane ay nasa 0.20 to 0.60. So habang lumalaki po yung tubo, tumataas din po yung value ng ating NDVI. So kapag umabot na po ito sa peak, ito po ay senyales na sa grand growth stage na po yung ating tubo. So in SRA, we are concentrating the sugarcane in sugarcane application, basically in the frequency which correlate in the growth of sugarcane, of our sugarcane, based on the basic development stage of an sugarcane. So in here, we can see the maximum peak of NDVI frequency or the other vegetation indices. And also you can compute the integral calculation for the total NDVI. Based po sa study ni Mauricio to determine the peak TC ng tubo ay nasa 250 days after planting. Doon po magpipeak yung value ng LAI or NDVI ng tubo. So habang tumataas po yung value, so ibig sabihin tumataas din po yung vegetation index value ng ating tubo. So based on the study of Mauricio in the growth indices and productivity in sugarcane, this was conducted in Brazil, tropical climate like the Philippines, and based on the recommendation of UP Diliman, UP training centers for the applied geodesy and photogrammetry during the YES project. Sila po yung mga partner ng SRA, si UP Diliman, para mag-conduct po ng study regarding on this study regarding po sa satellite images using LAI. Based on the yield, TC per hectare can be calculated using the leaf area index with the equation of area yield is equals to 21.8 multiply the LAI value. So ito po yung basis namin sa pagko-compute ng yield. So adding to the field data, we use satellite images for the crop estimation yield data we use Sentinel-2 with a 10-meter spatial resolution for potential yield data to determine to determination of and its yield determination and it's freely available to download. So this example na na-generate namin na mapa, makikita natin yung pagbabago doon sa year 1 and the year 2. Halimbawa, sa area na ito, in a snapshot, you can see na in the area na mas green pa, then we can assume na ito ay yung mga area na hindi pa na-harvest. Isipin din natin yung mga area na may lower value. Ano kaya yung mga posibleng nangyari o dahilan kung bakit mababa po yung value nila. So all of this data will be helpful on our decision making. For example, may mababang value, baka po pala ay infected ng disease or may mga insect na dumapo doon sa tubuhan. Ito po pala ay mga inatake ng armyworm. So dito po kinakain nila yung mga dahon ng tubo hanggat ito ay maubos at mamatay. At lilipat lang po ito ng ibang, yung armyworm nilipat lang po sa ibang tubuhan or cane hanggat maubos po nila yung mga leaves ng tubo. So isa rin pong indication kung bakit bumaba na po pala yung value ng NDVI or LAI, baka po pala ito po ay na-harvest na. So in this picture, ongoing na po yung harvest. So kaya po bumaba na pala yung value ng NDVI kasi wala na pong tubo sa area. Isa din po sa advantage ng paggamit ng technology o satellite, ma-monitor po natin ang inyong farm in a wide range. Kasi po, ang nakikita lang palagi ng mga farmers ang outside. So dito makikita natin napakaganda ng value. Mataas yung value sa outside. Sa boundary ng plots mo. Minsan po magtataka na lang po yung mga planter natin kung bakit bumaba yung kanilang yield. Pero nakita nila sa outside na ito ay napakaganda. Hindi po pala nila nakita yung mga nasa loob. Minsan pala ay ito ay mga kaya bumababa yung value noong nasa middle. Ito po pala ay hindi masyadong nasisinaga ng araw o kaya infected po sila ng sakit o kulang sa abono o pwede rin pong nag-lodge yung nasa gitna o hindi po napapansin ng mga farmers po natin yan kung hindi nila papasukin sa loob or kailangan po nilang gumamit ng ganitong technology para ma-monitor nilang maayos yung kanilang mga farm. So machine learning for image, computer can perform computation on numbers and it's unable to interpret image in the way that we do. So in here, with the help of DOST, ASTI, and their project, the core. Meron po kaming MOA between them na magpa-process na po kami ng mga satellite images sa kanilang facility, yung high performance computer. So dito po namin napaprocess at na-store yung aming mga data. Previously, ito po yung aming manual process ng yield. So dito, nagko-consume po kami ng isa or mahigit pang araw sa pagpaprocess ng isang image lang. Also, nag-acquire po kami ng Sentinel-2 satellite images sa USGS Earth Explorer. Pero nung nakapagtaya po kami with the OST, so with the help of Sir Ruel and Sir Nestor, nakapaggawa po sila ng automated process ng yield estimation namin. So dito, less than 5 hours lang po yung tinatagal ng isang image sa pagpaprocess. So dito po, hindi na po sa USGS kumukuha yung satellite. Hindi na po kami sa USGS kumukuha ng mga Sentinel-2 images. Dito po kumukuha na po kami sa Copernicus SARA. So ito lang po yung sample na running process ng yield automation. With the help of ASTI on the automation process of the yield. So sabi ko nga po kanina, the downloading of Sentinel images and processing the data, we now consume less than 5 hours in a one district map, at nakakapag-store po kami ng marami o malaki ng data compare po doon sa manual process po namin. So ito po yung mga sample outputs namin, which give you as a lot of information on a certain mill district. Dito po nakapaloob din yung mga historical TC, ton cane per hectare on a crop estimate data. We have also NDI modest 8-day interval na ito po ay free namin dina-download sa GLAM o Global Agricultural Monitoring System. Also, we have Jasmine data o JAXA Satellite-Based Monitoring Network System. Ito po ang website mula sa Japan na nagbibigay ng libreng weather data like precipitation, drought index, soil moisture, land water, index, solar radiation, and surface temperature and vegetation indices. So dito, sabi ko nga po kanina, mahalaga din po sa amin yung mga weather data para sa aming pag-estimate. Sino nga ba yung mga makikinabang sa outputs namin? On a national scale, the crop estimate outputs are used as a basis on sugar allocation and regulation technology improvement of SRA. So also the stakeholders or the farmers for optimization of cultural practices, variety, and soil fertility management. So yun lang po yung mga technology pillars ng ginagamit ng crop estimate system. So overall, the use of satellite data in sugarcane crop management can help farmers to improve productivity, optimize resources use, and reduce risks associated with the crop management. Sa ating lahat, matamis na umaga po.
Matamis na umaga din po, Sir Rolando Torres of the Sugar Regulatory Administration. So he is here present today to answer the questions from our audience during the Q&A portion. So satellite data is really an integral tool for our mandated agencies in the agricultural sector. And as the presentation earlier said, they have been using satellite data products even before the establishment of PhilSA. And it's so wonderful to see our agri-sector agencies and policymakers continuously and continually train and make use of new technology and keeping up with these new technologies in fulfilling their mandates. So may mga minimension siyang names earlier. I think some of them are who were part of the projects that have coordinated with the SRA before are already part of PhilSA as well. So we're hoping that with this, we could sustain and continue itong mga efforts po natin, as PhilSA is very much honored to assist in the fulfillment of the mandates of other agencies, given na meron kaming expertise in space and satellite data. And so I think we have a lot of questions dito sa ating Teams and sa ating YouTube video. And so let's proceed to the Q&A for two speakers, Ms. Dana and Sir Orlando. Kindly open your cameras. Yan. Dito na sila. Okay, so we've collated some of these questions, no, and we'll address them right now during the Q&A portion. Nasa Q&A portion na tayo. Ms. Dana, the first question is for you. This is very good information, but how can farmers use such? Ito po ay galing kay Anton Luis de Ocampo dito sa ating Teams. Ms. Dana.
Yes, thank you for your question. So I'd like to just share my screen. Let me know if you can see my slides.
Yes po, it's visible.
All right, thank you. Thank you, Joe. So this is the current setup of the operationalization of the SIICaP early warning system for drought developed by UP-ISM, DOST Pag-asa, and DSWM. And currently, the way it works is that the current drought maps are being developed in BSWM, and these are being disseminated to the Department of Agriculture, their DRRM offices, and these are being sent to the regional office, the different regional offices, and from the DARFOs, that's it is their job to relay the information to the municipal agriculture office or the provincial agriculture office, which then trickles down to information for the farmers. So they will essentially the maps are being provided to them, and then they translate it into whether or not farmers should act on this or not. And then in turn, they send us the drought damage report so we can continue to improve these products. So this is the current setup of how the project was set up. And while not formally set in stone yet, the Philippine Space Agency, PhilSA, will also be involved in improving these drought products.
Right. So basically, you're saying na important yung involvement ng ating farmers, and sila yung parang makikinabang talaga dito sa ating satellite data products produced by itong projects nga mentioned earlier in the presentation.
Yes, that is correct, Joe.
Right. Thank you very much for that. May tanong po tayo for both of you guys, Ms. Dana, Sir Rolando. Ano po yung GIS apps na ginamit ninyo for these activities that you have been doing? Mag-start po tayo kay Sir Rolando Torres from SRA.
Yes, ma'am. Ginagamit po namin sa GIS, QGIS po yung gamit namin, tsaka po ArcGIS o ArcMap po. So sa pag-process po ng mga images at saka pag-layout po. Yun po yung gamit namin.
Alright. Si Q is the open source na version and si Arc po yung paid natin na version po no, na GIS software.
Yes, ma'am.
Thank you very much. Ms. Dana, sa inyo naman, sa mga projects that you've been a part of, ano po yung GIS software na ginamit ninyo, especially those sa pinakita mo sa presentation earlier?
Yes, similar to Mr. Rolando Torres, we use QGIS, a QGIS software, since it's open source.
All right, thank you very much for that answer. So, ito, next question is for Ms. Dana. How can we use these data sets for our projects? Is it publicly available?
Yes, they are all publicly available. I'll just link here in the chat the link for the different data sets.
Okay. Sige po.
So
Sure.
those in the Teams meeting can see the link. So the input data sets are from NASA. They made them publicly available. But for those who wish to request the specific drought maps, please contact the following email.
All right. And ito po ay ilalagay din po natin sa ating YouTube na stream for those who are viewing on YouTube. Maraming salamat. Thank you for answering that question. We have another question for you, Dana. Do you have programs or plans for recommendation to appropriate agencies for this to land to the community or farmers? This is in relation to the question earlier about how farmers can use this information.
Thank you for the follow-up question. So, so far, the official SIICaP project has ended, and currently we're still in the development stage of the drought maps and the drought products that we are disseminating. As of now, there are no plans to actually sit down with the LGUs and talk about the implementations, although that may be one of the next steps that we can do to involve the LGUs to make use of the drought maps that we have developed.
Thank you very much for that. May question po para kay Sir Rolando from Nico Pante. Sir Rolando, sir, ano po yung best use cases ng paggamit ng SAR or optical sa pag-classify ng crops?
For me, ma'am, mas maganda po siguro yung optical kasi yung optical, ma'am, nakakatagos po ito sa cloud compared to the yung isa, ma'am. So mas maganda pong gamitin yung optical, ma'am, sa pag-classify kung anong crop po yung nakatanim. So sa ngayon po, meron po kaming study o trial ni Sir Ruel na ika-conduct dito po sa sa Larec at saka sa ibang district na sinusukat po namin gaano kataas yung tubo and paano mag-response yung tubo, and ipa-process po namin ito using the DTW and DTW para po ma-check paano mag-response yung tubo. Yun po.
Alright, thank you very much for that. So, dun tayo sa cloud penetrating na satellites po, no? Like yung mga radar and SAR. I think meron po kayong paper before about itong DTW or dynamic time warping. So, kung ililink po namin sa chat kung ano yung link to that paper, baka po may interesado po sa ating audience na mabasa po ito. I think si Sir Noel Borlongan pwede niyo pong i-type mamaya sa chat. Yung minention po ni Sir Rolando Torres na DTW or dynamic time warping. Okay. So, follow-up question po kay Sir Rolando. Ano po yung spatial or spatial resolution po of your satellite images? Galing po ito from UPLB.
10-meter spatial resolution po, ma'am.
Yes po. Sige po. Kasi meron po tayong follow-up question po dyan na ano po yung magandang spatial resolution po for monitoring changes in agricultural areas. Bago niyo po sagutin yan, may isa pa pong question. Saan daw po kayo kumukuha ng satellite images? Sino po yung source nila for the satellite images that you use for your research and operations?
So dati po nung manual process po kami, kumukuha po kami ng Sentinel-2 sa Earth Explorer USGS po. Pero sa ngayon po, ngayong automatic na po yung pagpaprocess namin ng mga satellite. Kumukuha na po kami kay Copernicus Sara.
Okay, Copernicus, tama. Okay, sige po. Thank you very much for that answer. May question din po tayo for Ms. Dana. May available na po bang spatial data para gamitin ng mga LGU to construct scenarios?
Hello po. So this is in relation to the link I sent earlier. So for the drought map, so that's also spatial data, please contact the email for the data.
Right, kasi meron din tayong question related to that, na how to contact you kasi they found your presentation very interesting. Yung sinend nyo rin po ba na link, na email address is a way to contact you, Dana?
I think may iba ng contact na din sa Facebook.
Okay,
But I
sige.
guess I can send also my email here since iba yung nag-manage ng email na yun.
Thank you very much. Would it be all right to also put it on the YouTube chat?
Sure.
Okay, we will do that as well. So for Mr. Paul Anthony Cordova, ito po yung email address ni Ms. Dana Ang, dana.ang@philsa.gov.ph. Okay. So sige po, Sir Rolando, may sagot na po ba tayo regarding po sa spatial resolution na question earlier?
Sa ngayon po, sabi ko nga kanina, the-download lang po namin ay 10-meter with 10-meter spatial resolution, pero mas maganda po, mas liliit yung resolution nito, mas ma-accurate po yung data na makukuha po natin. Pero sa ngayon po, meron lang po tayong libre na nada-download na with 10-meter spatial resolution. Kapag po mas bumaba yung resolution, mas maganda po yung nakukuha po natin data.
Okay, thank you very much for that answer, Mr. Rolando Torres. This is an interesting question from Teams. This is from Ryan Vilmore. After all of the partnerships that you've had with ASTI, PhilSA, the other agencies regarding space data, satellite data, in terms of funding, how much have you saved? How much has SRA saved?
Sorry, ma'am, ano po yung question?
How much, in terms of funding, how much have you saved after the partnerships with ASTI, PhilSA, and other agencies regarding satellite data?
Sorry ma'am, malaki pong tulong yung partnership namin with DOST, ASTI, and PhilSA sa pagpaprocess and pagda-download ng mga satellite images. Kasi sila lang po yung may capacity to generate this as technology. Kasi kung sa SRA lang po, kung siguro more than million po yung na-save namin sa pag-acquire. Hindi naman po lingid sa atin na napaka mahal po ng pag-acquire ng mga satellite data at saka yung mga facility like facility ng gagamitin like sa mga computer kasi kailangan mo po dito yung mga mas mabibilis na mga computer, hindi lang po yung mga common na computer na ginagamit po natin. So, yun lang po yung sagot doon, ma'am.
And on the side din po ng DOST, ASTI at PhilSA, nakaka-save din po sa mga fieldwork and yung mga expertise po on the ground dahil yung kayo po yung mandated agency regarding sa sugar regulation, pati na rin sa yung pinaka mas may knowledge po regarding this topic. So, importante yung collaboration talaga. Parang yung sinasabi nga ni Sir Nestor, Sir, magaling lang po kami sa computers, kayo po yung magaling talaga dyan sa mapping po ng sugar. Ayan.
Yes po, ma'am.
We have another question for Miss Dana. Regarding po ito sa drought again, is there going to be a system for decision support that will prompt or alert drought in an area?
Yes, with regards to decision support, there are already intergovernment agencies in place, such as the El Nino Task Force, headed, I believe, by NEDA, if I'm not mistaken. And also, Pag-asa is also involved there. And for El Nino, I believe they activated it during the last 2018 to 2019 El Nino, but this is still, I believe, sort of independent from the drought products that we've developed. So for the coming El Nino, maybe you can also get updates from them. And we are also looking into, PhilSA is also looking into partnerships with them with regards to agricultural drought. So these are still in the work.
Right. Thank you very much for that answer, Dana. We have a question here sa ating teams from Juan Enrique Macaraig. Is this only available for government agency? Mr. Macaraig, ano po ang ibig nilang sabihin dito? Kanino po sila nagtatanong? Care to elaborate po on your question? While waiting po for that, I believe Sir Torres of SRA has already put his email address dito sa Teams chat, and we'll also be putting that as well on our YouTube chat for those who wish to contact Sir Rolando Torres for any questions regarding the Sugar Regulatory Administration's mapping efforts using satellite data. So siguro, ito po bang mga data sets yung tinutukoy po nila, Sir? Sir Macaraig? Ito. Partnership with ASTI regarding satellite images. This is for government only. So I can speak on behalf of PhilSA na ito pong majority po ng ating mga ka-partnerships, yes, ay with government agencies kasi ito po yung pinakamadali na gawan ng MOA, MOU, and it's actually easier to coordinate with other government agencies. So if you're part of the academe or if you're part of a private sector, ang pwede po nilang gawin is to collaborate with a government agency na pwede po makipag-collaborate sa PhilSA regarding these satellite images. Ayan. So if you have further questions on this, you may contact info@philsa.gov.ph. At pwede, if you have questions naman po for DOST ASTI kasi they're not really represented here, I don't think they will be able to answer it, please email them at info@asti.dost.gov.ph. Ayan. May sagot po si Sir Noel Berlongan from PhilSA. So ang satellite images po ng DOST ASTI are currently being turned over from them to PhilSA. So eventually lahat po ng mga satellite data requests and partnerships ay dadaan na po siya sa PhilSA. So kung gusto niyo po silang i-contact, pwede niyo pa rin naman po silang contact, but you can also contact us with the email addresses that I mentioned. And we'll be typing them here on our chat. I hope we were able to answer your question, Mr. Makarai. Right. Thank you. Salamat. Naway nakatulong nga po kami sa inyo. Yan. Okay. Sige, mukhang wala na po tayong tanong for our Q&A. Going once, going twice. All right. So kung May mga tanong po sila para sa speakers natin. Their email addresses are in the chat box. Feel free to send them an email. Magpakilala po muna kayo na na-meet niyo po sila during the SIICaP Space Data Mobilization webinar. And I hope you guys learned a lot from this morning. Pero before we end this webinar, actually marami po tayong in store ngayon. Before we end this webinar, we actually have a fun and engaging game for you guys. And this fun and engaging game actually has prizes. So para po sa lahat ng gustong sumali, makinig po kayo sa mechanics. To facilitate this game, maybe call on Mr. Jomari Tabardillo from the Space Data Mobilization and Applications Division to explain the mechanics of the game.
Hello, good morning. Am I audible?
Yes.
Well, thank you.
Yes. Thank you. Thank you very much, Miss Jo. So good morning to everyone. I am Jomarita Bardillo from the Space Data Mobilization and Applications Division, and I will be your game master for today. And again, welcome to SIICaP. From the presentations, we have learned various applications of space data in agriculture, and we thank our speakers for this. So let's begin with our game. I'd like to share my screen first. So ayan, I'd like to emphasize that you might want to do your best, since for this session, may prizes tayo. We'll be giving away the coveted fills sa tumblers for the top 2 and 3 sa ating game ngayon na kahit kami, wala, char. And for top 1, meron tayong Mula plushie and 3 additional collectible holographic cards. So, for the game, pwede kayong pumunta sa menti.com and enter the code or use the QR code shown. So, ayan, meron na tayong 17 increasing. So, we'll wait for a bit. Sorry. Testing lang. So right now we have 32 players on the server. We'll start the game in a minute. So ayan, while we're waiting, you might want to review the the presentations. So okay, I guess we can start. We have 50 players. All right. So for question number 1, start the countdown in 3, 2, 1. So when did the latest El Nino occur? Option 1, 2018 to 2019. Option 2, 2019 to 2020. Option 3, 2020 to 2021. And option 4, 2021 to 2022. So time's up. All right, may 41 tayong tamang. So ang tamang sagot ay 2018. Yung latest El Nino occurred at last 2018 to 2019. So let's see who is leading.
Joms, hold muna. Stuck yung screen share.
Oh, okay. I'm sorry. Sige po. We'll wait before entering.
Jumps, there's a 5-second delay. So, pag sa change ng slides.
All right, sir. Thank you, thank
We're
you.
now at the leaderboard, so I think pwede na.
Okay, sige po. To proceed to the second question. Leading natin ngayon I see Carl Gustav with Millie. Second at third I see Ronald. Kaya pong makahabol ni John Miguel, ni Skids, and the others. So, bale, mas mabilis pala yung pag-pick nyo ng option, mas mataas yung points. Question 2 of 10. So what is the opposite of El Nino? For option 1, Santo Niña, option 2, La Niña, option 3, El Niña, and option 4, Maria Niña. Time's up. All right, so ang tamang sagot ay La Niña. Let's use leading. Miss ko na din mag-game si Dan. So na-overtake na, I guess wala na rin si first question. With 1,953 points, I miss mag-game si Dan. Second, Potato, and third is Lys or LYS. Ayun. Let's proceed to question 3. Which of these is not the one of the 4 main types of droughts? Socioeconomic drought, environmental drought, hydrological drought, or meteorological drought? Three, two, one. Time's up. So the correct answer is environmental drought. Since 14 lang yung tama, let's see who's leading. Okay, nauna pa rin si Imis mag-game si Dan. For second, Easy, and third, Gwen. Ayan, nagbago na yung top 3 natin maliban sa first. So, all right, maybe we can proceed. I'll just give a buffer time before proceeding to the next question for the others in the audience para makita din nila. Question 4. Which drought index presented only uses rainfall as its input? So we have RI, VHI, SPI, and SPTR. 5, 4, 3, 2, 1. Time's up. So ang tamang sagot ay SPI. Only 12 people ang nakatama. Oh, grabe naman si I miss mag-game si Dan. Still leading with Easy as the second. And na-displace na ating third, naging si Entoy na. Okay, so I guess kaya pa kong mahabol yung iba. Question 5. So answer fast to get more points. The combined drought index presented does not use which variable? Soil moisture, temperature, rainfall, or vegetation health? 3, 2, 1. Time's up. The correct answer is soil moisture. Dami sumagot ng vegetation health. I guess it's understandable then. And nagbago na ating leading si Easy na with 4,742 points. Wow. I miss mo game si Dan, still the second, kaya pang humabol. And Entoy with the third. So sayang naman, our prizes are very coveted. And yung actually yung iba wala din yung mga mismo field sa employees. So char. It is launched in order to generate rapid, realistic, and science-based estimates on annual cane production on district and farm levels. So is it SIICaP, YESS, SARAI, or BCAF? 3, 2, 1. All right, so ang correct answer is YESS. So let's see the updated leaderboards. Ayun, nakahabol na. I miss mag-game si Dan. But Easy still leading with 4,742 points. Second is I miss mag-game si Dan, and Entoy is our third. So let's proceed to question 7. For our last 3 questions. So what does SRA stand for? Sugar Regulation Administration, Sugarcane Regulation Administration, Sugar Regulatory Administration, or Sugarcane Regulatory Administration? 3, 2, 1. Time's up. So ang tamang sagot ay Sugar Regulatory Administration. Nice. Majority got the answer correct. So let's see the update. Oh, Easy. I miss mag-game si Dan and Entoy. Got it wrong, pero they are still on the top. Pero medyo close na ang contest ngayon with Liz as the third, and close fourth is Criselda and Jerome. Habol, Entoy. For last 2 questions. Question number 8. Which of the following is not a technology pillar of SRA? GIS, remote sensing, GPS, or robotics? 3, 2, 1. Time's up. So the majority got the correct answer. Robotics is the correct answer. Bilis naman pumindot. Okay, so for our first with 5,674 points, Easy. Second, Liz and Jerome. Third, close fourth, I see Entoy. Okay, so for our last question, hindi pa pala, question 9 of 10, sorry. The math is not mathing. What of the following index is used by SRA for yield estimation? Is it NDSI, LAI, VHI, or EVI? 4, 3, 2, 1. Time's up. And very even ang ating so the correct answer is LAI. 18 people got it correct. So tingnan natin ang updated leaderboard. Yan, Easy got it correct. Oh, displays ng ating recent second and third. Second and third natin ay si Joy and si Van. With Easy holding the first place with 6,577 points. So last question para humabol. Let's go. Final question. Which of the following applications are employed by SRA using space data? Is it mapping and area estimation, crop growth monitoring, yield forecasting, or all of the above? O curveball tong last question na to. Time's up. So let's see sino ang panalo. Oh, interesting. So Ayan, si Easy pa rin yung first. Congratulations to Easy for our second place. Dice, nakahabol, wow. And Jerome Mendoza for our third. So we'll be in contact with you, or you'll send us your details later for to claim your prizes. So for top one, Easy, you'll have a Mula plushie and 3 additional collectible holographic cards. And for Dice and Jerome, you'll have a Filsa tumbler. Thank you very much. So that concludes our game for this session. Thank you very much. So, Miss Jo?
Thank you, Joms, and to everyone who participated in the game. Ayan. So please don't, sa mga nanalo po, please don't forget to screenshot kasi yun po yung proof of winning nila. Yung screenshot po nila ay magpapatunay na kayo po talaga yung nanalo ng Mula plushie and one of these holographic cards showing you the different satellites of the Philippines and yung sa mga tumblers po natin. And we'd also like to take this opportunity to thank everyone for supporting SIICaP. So before we take our photos, before we answer the evaluation or feedback form, let's conclude this webinar series, this three-part webinar series, officially by welcoming Dr. Ariel Blanco, the Director of the Space Information Infrastructure Bureau. He will be giving his closing remarks for today's SIICaP. Sir Ariel?
Wala yata. Sorry, wala yatang camera. So, okay, so I'll just use my voice. Thank you very much for attending the SIICaP, Space Data Mobilization. And we thank the speakers, si Dana, tsaka si Rolando, no? So we have seen the different applications of remote sensing, space data for case of agricultural monitoring. And then there's a lot of things that we can do together with PhilSA, together with the Department of Agriculture and other agencies, as well as state universities and colleges. So there will be a call for image utilization and acquisition and utilization. So we welcome and encourage everyone to submit their proposals. So this will be launched maybe today or sometime next week. So as part of the space data mobilization, we hope to partner with a wide range of agencies, not only those dealing with agriculture, but also those working on different applications such as monitoring the environment, climate change, disaster risk reduction and management, and so on. So for the agricultural applications, so PhilSA is working also with DA in particular. Just recently, we have visited, for example, banana plantations in the Davao del Norte area in order to look at the condition ng fusarium disease, no. Kanina sa presentation ni Rolando, tinitingnan din or interested din siguro sila ang SRA doon sa pag early detect ng infestation such as yung army worms na binanggit kanina, and maybe other diseases then affecting sugar cane, no. So yun yung isang magandang application, and then of course repeatedly na mentioned, for example, yung NDVI, but there's a lot more things that we can work on or can utilize, and then we can also develop indices that are attuned to or develop or designed to indicate different severity of those infestation. And with the increasing availability, for example, of hyperspectral data, whether it's coming from drones, drones with hyperspectral data, as well as those satellites na may mga libre din pong hyperspectral data. No? So mas matitignan natin yung condition ng ating mga crops, ng ating mga sugarcane, ng ating banana, and other high-value crops sa Philippines. No? And so that basically are some of the applications na nakita natin. And for the next SIICaP, we invite you to join us again. And the next round of webinars will be hosted by the SMCOD, or Space Missions Control and Operations Division. They will focus on, say, other things like monitoring or managing our ground receiving stations, how these are actually operationalized or utilized for controlling and downloading data from our satellites. So again, we thank you for participating in this webinar. We thank the SDMAD for hosting this wonderful set of applications. So culminated by these applications in the agricultural sector. So with that, so thank you very much and good morning sa ating lahat.
Thank you very much, Director Ariel, for the remarks. Maraming salamat, and thank you very much for supporting SIICaP. And so for our audience, before we send the evaluation link, may we please ask for a photo opportunity with you guys. So please turn on your cameras if possible and hold your smile for a few seconds as our SIICaP team takes screenshots. Yan. Everybody, turn on your cameras para po may photo tayo.
Sige, wait lang natin yung iba.
Yan, nakapag-on na po ba tayo ng cameras?
Okay, I'm going for page 1 na. Okay, hold your smiles. In 3, 2, 1. And next page. 3, 2, 1, smile. Okay, thank you very much, everyone.
Thank you very much. And that's it for our webinar today. For our participants, please accomplish the evaluation form for you guys to receive your certificates of attendance. The link is posted in the chat box. We'll also be posting a link on our YouTube live stream. The important links po kanina, ilalagay din po ulit namin sa chat. The important links, email addresses. And yeah, that's it for our webinar today. So thank you very much for joining the mission, and please continue following the PhilSA journey. Visit our website and follow our social media for updates, and have a good rest of the day. Salamat po sa inyong lahat. Yung number 2 natin, second place po natin sa ating game kanina na si Base. Mag-send na po sila ng proof of your winning sa ating email, sicap@philsa.gov.ph.